In robotics and automation engineering department, we have research facilities in our lab for our PhD students as well as our project scholars. We have research graded instrument like real-time operating system development board from KIL with LPC 1760, with STM32, with J-Link debugger. We also have ARM Cortex NXP development board. We have RP LiDAR and other development boards. We also have 3D printer at our lab for R&D work. We have also developed a humanoid robot. We have named it Maria. It is a multi-purpose robot with features it can work as a receptionist. It can also work as security person. Also developed an advanced drone to be used for intruder detection as well as security purpose.
On behalf of the Physics Department, the Neotia University, I welcome you all in the Material Science Research Lab. Please come ahead. This is a state-of-the-art synthesis lab where we synthesize different nanomaterials and study their transport and magnetic properties mostly. This is a ACRB funded project lab. So let me show you some of the instruments we have here. This is a very good quality of method weighing machine. We have here centrifuge. We have the means to store samples in vacuum, hydraulic press, vacuum pump, and this is basically where we do some analysis work. And this is the wet part of the synthesis lab. Right. This is one of the instruments. It's known as fume hood, which we use as a clean room to synthesize nanomaterial. There is already a synthesis going on where we are trying to make a cobalt nanoparticle here. We also have the different tools by which we can synthesize 2D nanomaterials, basically graphene oxide, reduced graphene oxide nanocomposites, which are highly in research, which is a very hot topic of research nowadays. And we also have high temperature furnaces. These two are high temperature furnaces and vacuum oven. We also have gas flow system using which we can synthesize any nanomaterial in different atmosphere like argon hydrogen atmosphere or nitrogen atmosphere. So I welcome you all to visit our lab anytime and join us in collaboration of research. And for the students, it is if you want to study, if you want to learn about little bit about research, then it is possible. We are happy to help you, guide you, and it will be very helpful, beneficial for you for your future. Thank you so much.
Hello everyone, this is our microbiology research lab. So let's go inside and look out what is there. So as you can see, this is our lab. Here we do our research mainly on biofilm, inhibition, disintegration as well as plastic degradation. So here are several instruments. Let's look into that. This is the centrifugation machine. This is the trans illuminator. Here we have the gel system, the pH meter. Here we have the laminar air flow. This is our incubator shaper. Organisms are growing inside. We have refrigerator. Here is one of the chemical racks. This is our autoclave machine. Media has been prepared and it is being autoclaved right now. This is our weighing balance. And here we have the pipettes, several other tips and other lab essentials. This is our vertex machine, the colorimeter and the magnetic stirrer. And apart from all the instruments that we have seen, we also have the spectrophotometer. And lastly, these are all the publications from our lab. Thank you.
Okay, now I will show you two equipments. Okay, big equipment, small equipment already we have discussed. So these are big equipment. This is bakery oven. Okay, you can see the temperature is there, and just go inside so they can see cooking is going on. Okay, cooking process is going on inside. Okay, this is called salamander. This is called walk-in, where you can enter into the fridge. We'll set up all the racks and everything, so you can keep a lots of materials, your food items, everything inside this fridge. These are working table along with the ranges. This is called dough kneader. For your bread, dough and all, you can do the kneading. This is pickup counter. Actually these bulbs are very hot, so when you pick up the food, you have to keep the food over here, and then service people will pick up from here. This is called bain marie. This is the heater. We have to put water in this, then we'll keep the food here, so it will stay hot for at least 2 hours. This is your deep freezer. You can see the temperature -3. This is tandoor. You can make it as a gas tandoor, you can make it charcoal also. So you can see the wall, this is the wall made with the clay. Okay, this is your exhaust, and when you cook here, so all the smoke and everything will go up.
Hello everyone. So today we are going to showcase you demo bar setup that is there prevalent in many 5-star hotels across India as well as across the world. So here we have a bar setup done where we actually train our students, guide our students within the School of Hospitality and Culinary Arts.
Today we are going to give the demonstration of colony count. Colony count. Colony means when there is a microbial or the microbe growth on a 3D. Okay, we cannot see this in naked eye. It is not possible. So there 1, 2, 3, 4 microbial colony or microbial spore will be present. We can count the number, yes or no, but we cannot find it in the naked eye. So from there, colony forming unit or the colony number we used to find to this message. Clear? We will put that Petri dish contain that microorganism, already budding microorganism, young microorganism, not the old one. And we will put inside. We will put inside. There, what square boxes are there. Square boxes are there to count it. And this is the digital pen. This is the digital pen is there. Okay? Just like you do the digital sign, automatically they used to take the sign. There, we will put this pen. Whenever we will put the any colony like that, we will put the pen on that microbial colony and we will just point out. And whenever we will point out the number of colony that will be displayed on the particular area. Here you can see it. And ultimately by this way we will find out. Nothing else there. There only the zooming power is there. Zoom. There we will see the individual microorganism, okay, and we will just point out. We will point out on that microorganism, okay, and automatically this counter, automatically this will get counted. Clear? This is the, and once again you want to do the new, you will get the reset button, and you will get the 0. Clear? By this way we will do the colony counting of the microorganism, okay? Thank you.
Students, today we are going to perform or demonstrate about this machine. This is known as actophotometer or acetophotometer, whatever you call. Actually, actophotometer is used to measure the locomotor activity of the rodents or some animals you can or mammals you can tell. Here what's happened, actually here is some switch you saw here. Actually here is the circuits occur. When you place some rodents here and from the circuits there are some electrical impulses will be passed. Okay, that means you provide a shock on the rodents and they give some in reply they give some impulses with these shocks. Okay, then we can measure how much actually they give impulses. That's way we can measure the activity of the locomotor activity drag. We are going to demonstrate the rotor apparatus, how it is work to show you. So let's start. Okay. First of all, it is rotor apparatus which is used to perform the motor coordination of the rodent. Okay. That means here is the rod you see. Where rotate, that means rat or mice that are to be placed, and here you can start the start button and you can rotating through the desired minutes or desired seconds in no here. Okay. Here you can see that the rod is started and rodent has been trying to stay on the rod that by which you can perform the experiment of the rotor rod apparatus. Digital pH meter which is used to measure the pH of supplied sample. Okay. It is the electrode by which you can measure by dipping the in the solution, you can measure the pH of the sample solution. Okay. Here is the set button. Here is the set button by which by pressing which you can adjust the pH, and here is the screen from where you can detect the exact pH of the solution. Today we will demonstrate about the digital flame photometer. You see, first of all, here is the two instrument. It is the actually digital flame photometer and it is the air compression. What will happen here? Actually, if you see here, we put some water with the electrolyte. That means some electrolytes are there in the water solution. And here is the air compression. You see, actually, what's happened? You from here, you here actually a suction or a vacuum will take occur, by which with the help of the vacuum, this solution gets extracted, and here you see is the flame view. Here is some burning solution will be there, and from here when the solution passes through this pipe and just pour from the or flow from the fire, you got various light or various reflection as per the electrolytes. Okay, and here is you saw here data screen from where you can detect what actually happens or what actually the electrolyte present in your solution. Actually, কি হচ্ছে বলি এটা হচ্ছে ডিজিটাল ফ্লেম